Welcome back, everybody. It's inverse matrices time. Yippee, I hear you say. Well, why are we doing inverses of matrices? Well, it's pretty simple, really. What's your least favorite operation? Think of all your operations. Addition, it's pretty straightforward. Subtraction, a little bit harder, but still pretty cruisy. Multiplication, yeah, that's pretty good. Division, almost everybody's least favorite operation. So if we don't need to do a division, that's a bonus, isn't it? Well, that's where inverses come in. The one operation we can't do with matrices is divide. Okay, so let's have a look what an inverse actually is first up. Okay, simple equation, 4x equals 12. So what we have to do is we had 4 times x. We have to get rid of that 4 times. We want to end up with x equals something. So what we do with this one is the opposite of times is divide, and we have to divide both sides by 4. So 4 divided by 4 cancels out. 4 divided by 4 is 1. We're left with the x equals, and 12 divided by 4 is, of course, 3. So that's great if you can divide. In matrices, we can't divide. So we have to multiply by the inverse. What is the inverse, I hear you say? So this is divide by 4, yes? Okay. Have a look at the divide by. If you wrote a divide by sign, you would have a number over a number, wouldn't you? A dot divided by a dot. Sorry, dot divided by dot. So let's go back to this equation. We can also do multiply by the reciprocal, which technically is multiplying by an inverse. Let's have a look at reciprocal. Reciprocal of 4. What was reciprocal again? That was where you get a fraction and you flip it. So 4 as a whole number is just 4. But if you wrote 4 as a fraction, it would be 4 over 1, wouldn't it? The reciprocal of 4 over 1 is, flip it, 1 over 4. So we can multiply this by 1 over 4. Same as divide by. 1 divided by 4. Technically, we're doing that over here, multiplying by 1 over 4. That's great, but 1 divided by 4 is still divide by. A fraction, 1 over 4 is a fraction, and is divide by. Still no good to us, but can we write 1 over 4 a different way? Yes, we can. That falls on the bottom. So we can write that as a power. We can write that as 4 to the power of -1. Remember negative indices? If you've got a negative index on the top, it shifts to the bottom. If you've got a negative index on the bottom, it goes to the top. So have a look at this. 4 to the -1 can be rewritten as 1 over 4. So we're going the other way. Instead of writing times 1 over 4, we're going to write it as times 4 to the power of -1 on both sides. Same thing. So what do we do now? We cancel those two out, still cancels out. And now this bit's important to matrices. This inverse here, we need to write this before the 12 if we're writing it all on one line. So we'd write the x equals, and then we'd put in the 4 to the power -1 times the 12. We'll deal with that in a minute, but please get into the habit of writing 4 to the power -1 times what you had there already. That becomes important with multiplying. And of course, our answer is 3. Okay? Got that? So inverses mean what you've got to the power of -1. Great. On your class pad or your CAS calculator, really easy. All you need to do is type what you see. So one thing to remember though, inverses only apply to square matrices. Have to remember that. So let's have a look at this one. This is a square. 2 rows, 2 columns, that's a 2 by 2, so that's square. So if we needed to find our inverse on our calculator, all we would need to type in is the matrix to the power of -1, which is, type it in, enter, equals this. Straightforward. Another example. Is it square? 1, 2, 3 rows, 1, 2, 3 columns. Yes, that's a 3 by 3, so we can do that one. The inverse is, type it in the calculator to the power of -1 equals, there we go. Straightforward, done. Just do it on the CAS. But the bad news is sometimes you have to do it manually, so you have to know what you're doing. When would we use the inverse? It's not just about finding the inverse of the matrix. That's handy. That's what it is. This is the equivalent of 4 to the power of -1. 4 to the power of -1 is that, like we did on the first. So it's just matrix to the power of -1. But what does it mean? Well, we would use this particularly for solving simultaneous equations. Do you remember simultaneous equations? Here's one. That's a pair of simultaneous equations. A pair of equations we need to find the solutions to. If you're not sure about these on matrices, go to the Solving Simultaneous Equations video. Briefly, it is 2 times the x plus 3 times the y equals 50. That's one equation. Then we have 3x plus 5y equals 40. So there are 2 equations. We're going to solve for the x and the y, find out what they are. The beauty of doing this with matrices, you can have 6, 7, 10 simultaneous equations, 10 variables there. So as you've got 10 equations and 10 variables, you can use matrices and your CAS to solve them in one hit. Really straightforward. Let's think about the process for this though, how it works, just with the 2 by 2. All right, we need to end up with x, y equals something, don't we? So we have to shift this matrix over to the other side. How do we do that? We have the operation in the middle here, which is the times. We need to get rid of that. How do we do that? What's the opposite of times? Is divide, which is unfortunately no good to us. What is good to us though, instead of dividing it across, we multiply it by the inverse. So on your CAS, what you would do is, or before you hit your CAS, you would write this out, shift this over to the other side and write to the power of -1. So that's our inverse taken care of. Then we multiply it by our original matrix on this side. Once we've got that, we can just type this side into our CAS and we get the answer of x equals 130 and y equals -70. As I forewarned, doing it manually, you need to be able to do it manually. Now this has got a few steps. All right. See, it's got a few steps. It even told me it's got a few steps. And we're just going to do a 2 by 2 matrix. The good news is, if you are finding the inverse manually of a matrix, you will only be asked in year 11 and year 12 to find the inverse of a 2 by 2 matrix. Nothing bigger. 3 by 3, you just type it in your calculator and it'll give you the answer. 4 by 4, 10 by 10, whatever. Only a 2 by 2 you will have to do manually. The first step is we have to determine, good word that, determine, we're finding the determinant. It literally determines whether the inverse exists. So let's say we have a matrix A equals A, B, C, D. All right. All pronumerals, but it just shows you where things are. How we write the determinant is we write det for determinant of matrix A is, and to calculate it, we do this very simple calculation, AD minus BC. So we multiply the A times the D, then we go take away B times the C. What does that mean? Let's have a look. Here's an example, the matrix from before, 2, 3, 3, 6. So let's check if the determinant exists. We write the determinant A equals, we do the A times the D. So that was 2 and the 6. So 2 times 6. Take away 3 times the 3. Now, what does that equal? 2 times 6 is 12. Take away 3 times 3 is 9, sorry. And so our determinant equals 3. If the determinant does not equal 0, then there is an inverse matrix. Okay? This is important. If that equals 0, let's say that was 3 and 4. You'd have 2 times 6, which is 12. Take away 3 times 4 is 12. That means there is no unique solution. That means the two lines, when we put it in simultaneous equations, are either the same line, they go like that, they're on top of each other, sorry, I get that right with the camera, or they are parallel. They never exist. That means there is no one unique solution in either case. There's no solutions there, or there's no unique, no single solution. Okay, but again, dealing with that in simultaneous equations video. So the determinant has to not equal to 0. This equals 3, so that's good. That means we have a determinant. So here it is. If determinant equals 0, there is no inverse matrix. There is no unique solution. So this one, therefore, an inverse exists. Step 2, write 1 over whatever the determinant is out the front of the matrix. So let's write our matrix again. So here's our matrix. Haven't changed anything. But out the front, out here, we need to write 1 over the determinant, which was 3. Okay, so it's 1/3. Now, for the most part, a couple more steps. We need to swap the A and D values. So where's the A? That's the A. And there's the D. So we need to swap those two. So the 2's there, the 6 is there. They have to swap over and become 6 and 2. So first step, determinant, write the 1 over determinant at the front of the matrix. Then we need to swap the A and the D. So we've swapped the A and the D. Next step is we need to make the B and C values negative of their value. So these are both positive 3s. So they're going to become -3 and -3. If they were negative to begin with, what would they become? Positive, correct. All right. Last step, and you may or may not be able to do this depending on what your numbers. It may be worth it, it may not be worth it. Most of the time you'll get questions which are worth doing. We need to simplify if possible. This is a scalar multiplications. We've got a number at the front. So we're going to incorporate that into our matrix. So we have 1/3 times 6, which is 6 over 3, which simplifies to 2. We then do 1/3 times -3, so -3 over 3, which is, of course, -1. 1/3 times -3 down the bottom here, which is -3 on 3, which again is -1. And 1/3 times the 2, which is 2/3. We can't simplify that. So we could leave it as 2/3. Better than writing it as 0.66666 or 0.67 if you're rounding. Leave it as 2/3, unless the question asks you to. Okay? So the steps for finding the inverse. 1, try to do it on the CAS, much quicker. 2, if you have to do it manually, find the determinant, the AD minus BC. If your AD minus BC is 0, there is no inverse. If it doesn't equal 0, then we bring the 1 over the determinant at the front, swap the A and D values, and make the B and C values negative. And then simplify if you can. Okay, practice time. Hope the video has been useful. Good luck.